An outlier is any data value that stands apart from the bulk of the data. Now, when we say stands apart, how far apart does it have to be considered an outlier? Well, there's an outlier rule that gives you a criterion for determining if a particular observation is an outlier or not. Is it far enough away from the rest of the data to be considered an outlier? And here's the rule. A data value is an outlier if it is more than 1.5 IQRs below the first quartile or more than 1.5 IQRs above the third quartile. Now, these values, the first quartile minus 1.5 IQRs and the third quartile plus 1.5 IQRs, they put the boundaries on the data that are not outliers. And anything that's outside those boundaries is called an outlier. Now, those boundaries are called fences. And to calculate them is fairly easy. The lower fence is Q1 minus 1.5 times the IQR. Any data value that is less than the lower fence is an outlier. The upper fence at the other end is Q3 plus 1.5 times the IQR. And any data value that is greater than the upper fence is an outlier. It's a pretty simple rule to work with and to apply. So let's look at an example. We've got this data set 1, 2, 2, 2, 3, 4, 5, 6, 7, and 9. We already figured out the quartiles and the IQR for this, I believe. The first quartile is 2. The third quartile is 6. The difference between the quartiles is the IQR, and that is 4. Okay, to find the lower fence, take Q1 minus 1.5 times the IQR. So you plug in 2 for the first quartile minus 1.5 times 4 for the IQR. That's negative 1.5 times 4 is negative 6. 2 minus 6 is negative 4. So that's the lower fence. The upper fence is Q3 plus 1.5 times the IQR. That's 6 plus 1.5 times 4, or 6 plus 6, which is 12. Now, there are no data values in this set that are less than negative 4, and no values in this data set that are greater than 12. And therefore, the set contains no outliers. Now, if you have to demonstrate to your AP exam reader or to your teacher whether or not there are outliers in the data set, this is the general kind of presentation you want to do. State the quartiles, show how you calculated the IQR, find the fences, show all your work, and then compare the data values that you have to those fences and draw a conclusion. Here's a second example. Okay, we've got 10, 12, 9, 10, 13, 19, 11, 10, 13, and 9. These are not in ascending order. So figuring out where the quartiles is a little bit of a challenge, but you could do it. You could write the observations in order, or you could just put them into your calculator like this and find the 5-number summary. Okay, well, it turns out the first quartile is 10, the third quartile is 13, so the IQR is 3. The lower fence, Q1 minus 1.5 times the IQR, is 10 minus 1.5 times 3. 1.5 times 3 is 4.5, and 10 minus 4.5 is 5.5. We don't have any values lower than that in this data set. The lowest value is 9. So there are no low outliers. On the other end, the upper fence is Q3 plus 1.5 times the IQR. That's 13 plus 1.5 times 3. 13 plus 4.5 is 17.5. Now, we do have a value in the data set that is greater than that, 19. 19 is greater than 17.5, so 19 is an outlier. Again, if you have to use this rule to demonstrate whether an observation is an outlier or not, this is the general presentation you want to go through. Okay? Find your quartiles, find your IQR, find your fences, show your work, and then compare the fences to the data that you have and make a decision. Okay? So here your judgment is that there are no low outliers, but there is a high outlier of 19. You have to connect all the dots when you're doing this, and on your exam, if you fail to connect the dots, they'll probably mark you down for poor communication, and that's something you don't want to have to deal with. Okay? You should get all the points that your knowledge would allow you to. So make sure you have this communication in a format like that, and you'll be all right.